This video is about geometric series. Here is the formula. For geometric series, we have another formula. When absolute value of a common ratio less than 1, then S sub infinity equals A sub 1 over 1 minus R. For number 7, find the sum of this sequence. First of all, you decide this is an arithmetic sequence or geometric sequence or other specific sequence. We check since 7 over square root of 7 equals square root of 7, and 7 square root of 7 over 7, that's equals square root of 7. 49 over 7 square root of 7, that's a square root of 7. So it is a geometric sequence. For geometric sequence, here is the formula. We already got the R equals square root of 7. U sub 1, that's a square root of 7. Then N equals 12. So we just need to plug in S sub 12 equals square root of 7, 1 minus square root of 7 to the 12th power, then over 1 minus square root of 7. After we put into calculator, this will be the value. Now let's go to D. Still, we need to decide this is a geometric sequence. Any term divided by previous term, negative 1 over square root of 2 divided by 1 equals negative 1 over square root of 2. 1 over 2 divided by negative 1 over square root of 2. You will get negative square root of 2 over 2. For this one, we simplify that is a square root of 2 over 2. Then negative 1 over 2 square root of 2 divided by 1/2. You will get negative 1 over square root of 2, which means negative square root of 2 over 2. So it is a geometric sequence. Then we can use this formula. U sub 1 equals 1. R equals negative 1 over square root of 2. Negative square root of 2 over 2. Then for N equals 20. Therefore, we got the S sub 20 equals U sub 1, that's 1 times 1 minus negative square root of 2 over 2 to the 20th power. Then over 1 minus negative square root of 2 over 2. After you put this into graphing calculator, you will get 0.585. Find the sum of each of the following infinite geometric series. For A, we check this R equals 12 over 18. That is 2 over 3. Less than 1. Therefore, you can use this infinite geometric series formula. That is S sub infinity equals A sub 1 over 1 minus R. a sub 1, that's 18. So 18 over 1 minus 2 over 3. You will get 18 over 1 over 3. So jump. You will get the 54. For B, R equals negative 3 over 6. You get negative 1 over 2. Still, absolute value, that's less than 1. Therefore, R sub infinity equals A sub 1 over 1 minus R. A sub 1, that's the first term, 6. 1 minus negative 1 half. So you get 6 over 3 over 2 equals 4. For number 9, write as a rational number. For C, 0.53, there's a bar above 53, which means 0.53, 53, 53. Keep going. Therefore, we can write down 0.53 at 0.0053 at 0.00053. You could say this is a series of geometric sequence. R equals 0.0053 over 0.53. That equals 0.01. And U sub 1 equals 0.53. We can use S sub infinity equals U sub 1 over 1 minus R. Therefore, we got 0.53 over 1 minus 0.01. So you get 0.99, 0.53. So you will get 53 over 99. For D, we can write down 0.415 plus 0.000415 plus 0.00000415. So we get the U sub 1 equals 0.415. R equals 0.000415 over 0.415. That is 0.001. Therefore, U sub infinity equals U sub 1 over 1 minus R. So we get 0.415 over 1 minus 0.001. So we get 0.999 as denominator, 0.415. Therefore, 415 over 999 will be the rational number. For number 10, evaluate this series for C. According to the formula for sigma notation, this one, we can write down that is S20 minus S k minus 1, that's 3. This is an exponential function. Therefore, we could see this is a geometric sequence. We know base equals R, that is a negative 2. We got to use this formula to figure out S sub 20 and S sub 3. We need to know U sub 1 equals 3 times negative 2 to the first power. Therefore, you got negative 6. As long as you know the first term and the ratio, you can get geometric series. Therefore, S sub 20 equals U sub 1, that's negative 6, 1 minus negative 2 to the 20th power, over 1 minus negative 2. You will get the 2,097,150. For S sub 3, we plug in, we got negative 6, 1 minus negative 2 to the third power, then 1 minus negative 2. You will get negative 18. Therefore, S sub 20 minus S sub 3 equals 2,097,168. For E, this is an exponential function. Therefore, it's a geometric sequence. We can use a formula, this one. So R equals negative 1 over 3. U sub 1 equals 9 times negative 1 over 3 to the first power. That is negative 3. According to this definition, we know this sigma notation equals S sub 12 minus S sub 2. For S sub 12, we plug into this formula. You will get negative 3 times 1 minus negative 1 over 3 to the 12th power. Then 1 minus negative 1 over 3. You will get negative 2.25 for S sub 12. S sub 2 equals negative 3 times 1 minus negative 1 over 3 squared. Then it's 1 minus negative 1 over 3. You will get negative 2. Therefore, S sub 12 minus S sub 2 equals negative 2.25 minus negative 2. That is negative 0.25. For G, it's looking for the infinite series for geometric sequence. This will be the formula we got to use. We know this is an exponential function. Let's change into exponential function standard form. That I can write down 5 times 1 over 2k, which means 5 times 1 over 2 to the kth power. Therefore, we could say R equals 1 over 2. We are looking for A sub 5, then equals 5 over 2 to the 5th power. That is 5 over 32. Therefore, for this summation equals a sub 5 over 1 minus r. So we get 5 over 32, 1 minus 1/2. You will get the 5 over 16. For number h, this is an exponential function. Base will be the ratio. And a sub 2 equals 6 times 3 over 4 square. That is 6 times 9 over 16. Reduce 3, here's 8. So we get 27 over 8. Now for this sigma, we got a sub 2 over 1 minus r. So 27 over 8. 1 minus 3 over 4. That is 27 over 2. Now let's go to 11. A geometric sequence has partial sums s sub 1 equals 3, s sub 2 equals 4. We know that s sub 1 equals a sub 1 equals 3. S sub 2 over s sub 1 equals r to the first power. Therefore, 4 over 3 equals r. So for A, we already got 3. For B, we already got ratio 4 over 3. Then calculate the fifth term. For C, u sub 5 equals u sub 1 times r to the 5 minus 1's power. Therefore, u sub 1, that's 3 times 4 over 3 to the 4th power equals. So 256 over 27 will be u sub 5.